Okay, so in these slides, we will be here looking at the AWS KMS key management service. So anytime you hear encryption in AWS, you have to think about obviously, and it's a way to easily control access to our data, and AWS will manage the encryption keys for us. It's fully integrated with AWS, and will manage the encryption keys for us. It's fully integrated with IAM for authorization and has seamless integration into all the AWS services pretty much. So EBS like Redshift, RDS, SSM, etc., etc. So we can use the CLI or the SDK to interact with KMS, key management service. So in KMS, you have two types of keys. You have the symmetric keys and the asymmetric keys. So the symmetric keys were the first offering of the KMS. It's in the single encryption that will be used to encrypt and decrypt information, and then all the services that are integrated with AWS KMS use the symmetric KMS keys. It's necessary if you want to do the envelope encryption and you never actually get access to the KMS key itself or unencrypted. You must just send data into KMS, and with the KMS API KMS API call to use it. So now the asymmetric key are new, and they can allow you to have two kind of public keys. It's a key pair, so it's a public key and a private key. The public key will be used to encrypt and the private key will be used to decrypt. So now this is very helpful when you want to have encrypt or decrypt or sign and verify operations. And you can download the public key. That means that you can encrypt stuff from anywhere with a public key, and you can send the public key to people that you don't trust in untrusted environments. But once the data is encrypted with the public key, only the private key has the power to decrypt your information, and you still cannot use the private key unencrypted, though you have to use the KMS API calls. So the use case for an asymmetric key is to have encryption outside of the AWS by users who cannot directly call the KMS API for whatever reason. Okay, now you have different types of KMS keys. The first type is customer managed key, and this is the key you create directly in KMS. So you can create, manage and use them. You can enable, disable them. You can enable a rotation policy to rotate the key every year while the old key is still preserved. Of course, and you can add a key policy, which is a resource policy for KMS keys, and you can audit the key uses in CloudTrail. So this is the kind of the keys you will leverage for envelope encryption. So these are the kind of keys that you will manage yourself. Therefore, they are called the customer managed keys. But a second kind of key is the AWS managed keys. So these ones are used exclusively by AWS services such as AWS S3, AWS EBS, and so on. So this is what you see in the UI when you use the AWS managed keys. So you see the AWS managed keys all the time whenever you are actually encrypting an EBS volume or like S3 volume. So they are managed by AWS, and they are automatically rotated every 3 years. So you can view the key policy and you can audit in CloudTrail, but you cannot leverage them for your own encryption operation. And finally, you have AWS owned keys, and these are created and managed by AWS, used by some services to protect your resources, and they can be used across AWS accounts, but they are not in your accounts. They are used by AWS internally, and you cannot view, use or track or audit these keys, but AWS tells you that these keys actually exist. Okay, so now if we want to have a summary of the different types of KMS keys. For the customer managed keys, you can manage metadata. You can view metadata, and you can manage it, and you can also use for your accounts, and you can have an automatic rotation every 1 year. But the AWS managed keys can be used in your accounts, but you cannot manage them. And they are required to be rotated every 3 years, and this is automatic. and then the owned keys, you just know that they exist, and but you cannot use them or even see them. So now, uh, how do you create a KMS key? So you have what's called a key material origin, and it cannot be changed after creation, so you have to define it at the creation time. You have the KMS, which is called the AWS KMS Key Material. That means that you are going to have KMS automatically created, generate and manage the key in its own key store to see what happens. And when you go into the KMS and start to create a key, but you have a second option called external. In that case, while you import the key material directly into the KMS key, and you are responsible for securing, managing this key material outside of AWS then. Okay, so maybe you just want to create it outside and then import into this KMS and then be done, and delete it in your own end, or you just want to keep a copy in KMS, and therefore you are responsible obviously here for the copy outside of KMS. Now the last option is to use a custom key store called AWS CloudHSM. So this allow you to create the key material directly within your HSM cluster, that the hardware security module cluster, and manage the key material there. So let's consider here. So let's consider that how it works. Let's consider how it works when you have a custom key store, which is backed by CloudHSM. So you create a CloudHSM cluster as a custom key store, and there was a Dart integration with KMS. That means that when KMS creates key, well, the key materials are going to be stored in your hardware security module HSM cluster that you own and manage. That means that the keys live within your HSM cluster. They are only managed by KMS and used by KMS, and all the cryptographic operations will be directly performed in the HSM. So this is the architecture. You have your CloudHSM cluster with two AZs, and it is directly connected to KMS. So once you have at least two HSM for high availability, and maybe you will be able to see this one now, there the HSM, CloudHSM. And then you can integrate with KMS, and then the users can still use the KMS API to view, create and manage the keys. But behind the scenes, you know for sure that the KMS will be using your CloudHSM cluster for all the cryptographic operations and for storing and retrieving these keys. So why do we have to do this? So well, the use case is that you need to have direct control over the HSMs for higher security, or for like the risk security requirements at least, and then the KMS keys probably maybe then. They want to be in the dedicated HSM, or maybe you need to have a regularity requirement to have FIPS 140-2 level 3 as level of security, because the KMS was only validated at level 2. KMS is only level 2, but the Cloud HSM is level 3. One of the use cases that I've recently read about is some of the like the UPI transactions happening in India, and the merchant cryptographic keys is usually they say that the bits being stored as the Cloud HSM hardware security module, and those are the dedicated hardware security module, and those are actually on-premise servers. So this is what actually just I heard recently. So now here we'll be moving on. So now if you choose to have an external KMS key source, then you can bring your own key using your own key material, and you are really going to be responsible for the key material security, availability and durability outside of AWS. So it must be 256-bit symmetric key. So you cannot import asymmetric key material for now, and it cannot be used with the custom key store. It has to be used on its own. So for this, if you want to have KMS key rotation, of course, because the key source is external, then you have to rotate in your own CloudHSM. So automate rotation is not supported. So how does it work then? So well, the user will create the KMS key in KMS and say that it's a symmetric type of key, and the source is external. Now the key envelope is created, but the key material is not. So then you download the public key and an import token, and you are going to use the public key, with your externally generated key material to create an encryption. And thanks to the public key here, So now this private key that has been encrypted can be sent back to the KMS service using also the import token, and then KMS will use some decryption mechanism to get the key material and store it in your KMS keys in there. So KMS key in there. So this is the process of importing external keys in KMS. Okay, lastly, so you need to know about KMS multi-region keys. So it's possible for you to create a key, for example, on like a USist one region and have it replicated across multiple regions. So they will have the same key material and actually the same key ID, but it will be in the different region. So So the use cases are amazing because thanks to this, well, you have the same key in the multiple regions, and that means that you can encrypt in one region and decrypt in other regions using the same AWS KMS key ID. So you don't need to re-encrypt data or make cross-region API calls. So they will verify, they will have the same key ID and the same key material, the same automatic rotation, and so on. So, but these keys are not global keys, and it's the principle that there is a primary key in one region, and all the others are the replicas of that primary key. So each key can be managed independently, and although you can only have one primary key at a time, it's possible for you to promote one replica into their own primary key. So the use cases for multi-region key is going to be the disaster recovery cases, global data management, for example, for DynamoDB global tables, active application that span multiple region, or distributing signing application, and so on. So that's it for the KMS lecture, and I hope you liked it, and I will see you in the next lecture. That's going to be the parameter store.